So today we're going to be talking about arithmetic sequences. The first thing we need to define really, I guess, is a sequence. And most of you know that a sequence is a set of numbers in some kind of a specific order. So for instance, 3, 5, 7, 9, and on. You'll notice those are the odd numbers, but it's also a sequence because to get from 3 to 5, I'm doing that plus 2 every time. Okay? And because I'm adding or subtracting, really, because those are inverse operations of each other, this is called an arithmetic sequence. Meaning that the difference between the terms is the same. And sometimes we call this having a common difference. So each time the difference between 3 and 5 is 2, the difference between 5 and 7 is 2, the difference between 7 and 9 is plus 2. It's the same thing. The next number in my sequence would then be 11. Good. So let's look at another sequence because the odd numbers are just a little too easy for you guys sometimes. So let's look at a little bit different. We'll start with 33, 29, 25, 21, 17, and so on. And I want to find what it takes to get from 33 to 29. And it has to be addition or subtraction. So I know 33 minus 4 is 29, and 29 minus 4 is 25. 25 minus 4 is 21, and so on. So my common difference, which we've called D, is negative 4. And because it has that common difference, is this an arithmetic sequence? Good, it is arithmetic. It's arithmetic, but Mrs. C can't spell. Darn. Okay, let's look at another one. 1/2, 5/8, 3/4, 3/16. Dot, dot, dot. Well, first of all, finding common denominators would be important. The common denominator between 2 and 8 would be 8. To get from 4/8, which is the same as 1/2, to 5/8, I have to add 1/8. To get from here to here, again, common denominator is 8. 5/8 to 6/8, I'm adding 1/8. So you may look and see that these two share the same difference. Is it the common difference? Well, that would require us to look at this third movement. And the question is, from 3/4 to 3/16, what am I adding? Good, you're going to add 1/16. Is 1/16 the same as the differences here? No. So this would be not arithmetic. Okay. When we are looking at an arithmetic sequence, our first term we will call it ace of 1. When I have this 1 not as an exponent, but at the bottom, we call it ace of 1. If it was a B, it would be B sub. It kind of has that like CE sound to it. Our second term would be, we have ace of 2 equals that ace of 1, that first term, plus our common difference. And if I did an example column here, if my first number was 3, and we'll look at this example we did first with the odd numbers, my second number was 5, and 5 is equal to 3 plus our common difference of 2. Our third term, ace of 3. I can say it's ace of 2 plus d. That's awesome. But let's write it in terms of ace of 1. It's ace of 1 plus 2 times the common difference. So 7 was equal to 3, which was our ace of 1 term, plus 2 times our common difference, 2. Our fourth term, ace of 4, is ace of 1 plus 3 times the common difference. So 3 plus 3 times 2, that's 6 plus 3 is 9. See, we're getting that 3, 5, 7, 9. So let's write the fifth term. How would we express it in terms of ace of 1? Good, it would be ace of 1 plus 4 times d. And we can keep going and keep going. But eventually we want to talk about our nth term. And our nth term is just ace of n and we will write it as ace of 1 plus, if it's the nth term, let's think about it. When it was the fifth term, this isn't 5. It's not the n times d. It's 1 less than n. So n minus 1 times d. This part down at the bottom, the nth term part, is important to remember. Okay? And let's look at some examples where we would use it. So let's say we start with a sequence, -12, -8, -4, 0. First of all, I need you to find that common difference. Yes, the common difference is 4. Okay? And I want to find the 9th term in a sequence. I have the first 4. I want to find the 9th term. Well, that would mean, to find ace of 9, that our n value is 9. So instead of writing out what the next 5 terms will be, I'm going to use an equation that ace of n equals ace of 1 plus n minus 1 times d. And remember, anytime I see that n, I'm looking for the 9th term, so we're going to plug in 9. So ace of 9 equals ace of 1 plus 9 minus 1 times d. So there's a few things I can plug in, a few values I know. I know the first term of my sequence is, yes, -12. I know that 9 minus 1 is, hopefully you know it's 8. And I know that my common difference, d, is, good, 4. So I can plug in, or I can go ahead and find ace of 9. -12 plus 32 would give me 20. And that is my 9th term in the sequence. There's another way to kind of do this, especially if we don't know what they're going to ask us for. Like, what if we didn't know it was the 9th term they were going to ask us for? Maybe I should just go back and scroll down. So let's say we just want to find what the nth term is. There's still things we can plug in. We can say a sub n is equal to a sub 1 plus n minus 1 times d. That is not going to change. Okay, it's just not. And the first term we always know is that negative 12. We also know that for this sequence, the common difference is always going to be 4. And what we can do with this is just distribute that 4 in there. So we'd have negative 12 plus 4n minus 4. Well, now I see that I have some like terms. And maybe I want to combine those like terms. So I have 4n minus 16. Okay? And that's my a sub n term. So maybe they ask me to find that first, and then they tell me that they want me to find the when n equals 9. Well, let's see if we plug it in and get the same answer. We get a sub 9 equals 20, which, hint, is that same thing we got up here. Okay, but we just simplified our equation a little more before solving and plugging things in. Okay, so a lot of times they will ask you to find this nth term before they ask you to do anything else. Let's try another one of those. And I'm not going to ask you to find any particular term, just the nth term of a sequence. So our sequence is negative 3, negative 8, negative 13, negative 18. First of all, find that common difference. Well, as I move from each number to the next, I realize that I'm subtracting 5. So my common difference is negative 5. Now, our equation hasn't changed. Okay. Let's go ahead and we're just going to find that nth term, but let's plug in what we know. And now I know I can distribute so that I would get negative 3 plus negative 5n plus 5. Be careful with those negative signs. And combine like terms so I find that a sub n. Go ahead and tell me what the a sub n term would be with values of n, or in terms of n. Good. If I combine like terms, I will get negative 5n plus 2. Okay, and then from there, whatever they tell me n equals, I can find really easily. Okay? And we're going to be working on this a lot more in class tomorrow, so you will have lots of practice. Okay? Thanks for watching.